Okay, so I think most of the people have joined in, and we can start right now. So thank you all for your patience, and thank you for joining us today's webinar. Uh, so welcome. This will be our today's introduction to RISA Foundation software, and which is a software for applications at or below grade. Myself, Ashwin Nagar. I think most of you might already know me. I'm from Acero Consulting. We are the channel partners of the Mission Group, and it's honestly great to have you all here today. In this session, we'll focus on RISA Foundation and how it simplifies the design of foundations and below grade structures, how it helps you work faster, more accurately, and with greater confidence. Right. So thank you for being with us this afternoon, and let's get started. Coming to what we'll cover today, here's a quick look at today's agenda. So we'll start with a brief introduction to RISA Foundation, followed by its critical features. Then we'll move on to the live showcase of the software and see how it works in practice. We'll also cover integration with RISA Suite and discuss licensing, support, and finally wrap up with Q&A session. So here's what you can expect to take away from today's session. So first of all, you'll gain a strong understanding of RISA Foundation's capabilities and how advanced features support efficient foundation design. We'll also share best practices so you leave with the confidence to apply RISA Foundation effectively to your projects. And finally, we'll point you to the resource material like documentation, tutorials, and we'll also share a participation certificate in the end. So your learning continues even after the webinar. Right. Before we begin, I'd like to introduce you to our presenter, Mr. Kirti Joshi. He is our in-house structural engineer at Acero Consulting Engineers. Kirti holds MTech in structures from Delhi Technological University. He has hands-on experience with softwares like RISA, Adapt, Bluebeam, Idea Statica, RFEM, and many more. And he will be taking you through the detailed technical walkthrough in just a bit. Before we dive in, here's a quick view at what Acero Consulting is and a few words about us. So we are proud to have worked with more than 300 clients in the past year, and we have delivered more than 30 products and supported projects across 20 plus locations. And that is not only limited to India. Our team is made up of postgraduates from top universities, and we help clients enhance their productivity, streamline their workforce, and get the most economical solution possible. We do that through knowledge posters, webinars, resources, and we ensure that you are learning and extracting value out of your software journey. Right. Coming to the products. Today, here's a view on what our software is from the Nimishek Group. Right. Firstly, we have RISA Foundation. So RISA Foundation we'll be focusing on today. And we have other RISA Suite like RISA 3D, RISA Flow, RISA Connection. That's for integrated modeling and connection design. We have Adapt Builder and PTRC. That's for reinforced concrete and post-tension concrete design. Allplan is a BIM-based design platform. Finally, Bluebeam, which is a smart PDF collaboration tool for AEC professional like us. So, along with the Nimishek products, we also have products like Autodesk, Idea Statica, Shuriken, Adobe, and Aries Trinity from Weber. So Aries is a alternative to Autodesk, which also provides perpetual licensing. So if you're interested in anything other than RISA, you can obviously trust in Acero to provide all the software that you require. So with that quick overview, let's dive into RISA itself. I'll now hand over to Kirti, who will take you through the software and its core features. So Kirti, over to you. Thank you all once again for joining. Thank you.
Yeah, thank you, Ashwin. Hope I'm audible, right?
Yes, Kirti, you are audible.
Yeah, hi, good afternoon, everyone. And again, thank you for joining us for the today's session. Yeah, my name is Kirti Chandra, and I'm the structural engineer and From here, I will take you into the RISA Foundation, where we will explore the software capabilities for the design of foundation system. So as you can see in the slide, so RISA Foundation is a specialized software from the Nemetschek group, which is developed for the foundation analysis and design. So this software can work independently, but at the same time, it is easily integrated with the RISA suite, specifically the RISA 3D and the RISA Flow. I mean, for example, if you have completed your superstructure analysis in the RISA 3D, then you can integrate a RISA 3D model with the RISA Foundation, where the reactions come directly into the foundation model. So instead of the manual transfer, you are working with the Excel force from the superstructure, which improve both the accuracy and the efficiency. And yes, you can design the different foundation elements like the spread footing or the combined footing, the mat, the pile system, grade beams, and the retaining wall. Will also show this in the software showcase today. And the software is compatible for the Microsoft Windows 8 if you have the 1 GB of RAM for 32-bit of computers and 4 GB for the 64-bit of computers. So moving forward, here are some of the key technical features I have highlighted that makes the RISA Foundations practical for our everyday engineering work. Like starting with you can model the mat slabs, the grade beams, like I mentioned, the piles caps or the retaining walls, the footings spread, isolated of the combined footing. So it also has the ability to model the slabs of any of the arbitrary shapes. Like for example, in real, like the foundation rarely follows the perfect geometry, like the rectangular geometry or any other. Like there may be the setbacks or the lift pits or the shear wall cores of the basement. So the software allows you to define the bearing slab thickness as well, like the openings and the discontinuities. For example, I mean, in a mat foundation, like it is common to regarding the modeling feature, like pedestal can be added to the spread footings or the slabs, or whether like you can define the variable soil properties across a model. For example, if a geotechnical report that shows the different SBC values in the different zones, you can assign them accordingly within the RISA Foundation. Next is you can impose the point supports anywhere in the model. Basically, the point support can be the rigid or the tension only, or the compression only, or the tension or the compression spring. Yeah. And last feature I would like to highlight is the automatic generation of the circular mat slabs. This is commonly required for the structure like the circular tanks or the silos. Instead of manually drawing the geometry, the software provides you the template that could definitely speed up your modeling process. Which make it easy, to modify the foundation layouts.
It is just a minute. I think we are having some technical problem. Your voice keep cutting. Can you just close the background apps or something that might be running?
My voice is not clear. I mean.
Hey, your voice is clear. It just from time to time it just keeps cutting. So can you just real quick just delete all the softwares or close all the softwares that are running in the background?
No, I haven't actually opened any of the software in my background.
Okay.
I don't know
Okay.
what's
Let's
the issue.
continue. Let's continue.
Okay, you can again pause. You can again pause me if
I'll
you face
intimate
any
you.
of
I'll
that
intimate
issue,
you. No
right?
problem. Yeah.
Okay, so yeah, regarding some of the analysis capabilities, like the RISA Foundation, you can see automatically generate the finite element mesh that is using the quadrilateral elements. And also the physical members are used for the grade beams with the automatic, inclusion of the internal, like the internally generated of the mesh points. The next is like the soil spring stiffness that is calculated automatically based on the modulus of the subgrade reactions you define, and also based on the slab tributary area. So actually this helps to simulate, the soil structure interactions more realistically, like compared to the fixed or the rigid support. Also, you can include the passive pressure and the soil overburden in the slab analysis. And definitely, yes, you can apply the point load, the point moment, the line load, or the path loads anywhere in the slabs. And self weight of the slabs and the beam is automatically calculated. And you have the options to exclude it into the analysis as well. And the last is it includes the response spectra analysis result from the RISA 3D model. This may be important for the seismic design, as foundation force are derived, directly from the dynamic analysis, if that is carried out in the RISA 3D, and if you are about to integrate that RISA 3D model with the RISA foundation. So moving forward, here are some of the design related features, as you can see on the slide. First is you can draw the design strips or the design cuts easily anywhere on the your slab, and it will calculate the rebar requirement for each of the design strips you have created. And based on that, the software will provide the design for the bending and the shear for all of the design cut. The software checks the critical sections throughout the slab, and the software can also design the pedestal on the mat slab or the spread footing, which is useful like when columns load are high, or when the column base levels need some adjustment. And the next is like the grade beams are automatically designed and detailed, which saves a lot of the manual effort, specifically in the large foundation system. So for the pile supported foundation, pile cap reinforcement design and the shear checks are carried out, by taking care of both the safety and the compliance. It also supports the retaining wall footing design, and it take care of the seismic loading on the retaining wall as well. Yeah. And the next is the software with the RISA foundation. It performs the automatic code-based load combination generation, as well as you have the options to define your own load combination as well. And last is the automatic punching shear are performed for the mat slab, which is one of the most critical check in the foundation design. And the software also supports the concrete, the steel, and the wooden piles, and have incorporated all the design code specific for the steel and the wood pile design. So I hope my voice is clear right now. So
yes, PP, yes. Till now it's not disconnected. If it does get disconnected, I'll let you know. Yeah.
Yeah, thanks.
You can just
So
continue.
here are some of the applications and use of the RISA foundation where it is being widely used for the project. For example, for mat foundation, the RISA foundation is used to design the large mat slab. For example, if you're working with the commercial building or the hospital or the high-rise structure where the loads are heavy and distributed non-uniformly, and that required the detailed finite element analysis. Because as the simple hand calculation or the strip method are often not sufficient. So for example, if a core wall carries significant higher load than the surrounding column, you can clearly see the higher stress and the reinforcement demand in that region, so that it helps engineers, to optimize the slab thickness and the reinforcement, instead of over designing the entire mat slab. So now for the isolated or the combined footing, the software is also useful when the column layouts are complex, such as near the property lines, or where the spacing constraint are exist as per the architectural layout. So next is for the pile foundation, pile foundations are commonly required when the surface soil is weak or the highly compressible, like in such case, like the loads need to be transferred to the deeper section. RISA Foundation allows you to model the pile groups and the pile caps, including the pile spacing, the pile stiffness, and you can see the interactions, pile cap interaction as well. As you can see, for the retaining system, like the retaining wall can also be modeled together with the foundation system that allows the lateral earth pressure and the foundation interactions to be considered simultaneously. So with the RISA Foundation, like you can carry design foundation of any type within a single model. So here's the first interface of the RISA Foundation. Like the user interface of the RISA Foundation is set to provide the uniform workflow that allows the engineers like us to get the most out of any of the software. So each area of the interface of the specific purpose, for modelings and analyzing or documentation of the project, you can see that these sections we will also show in the software showcase right after this. This is the top quick access toolbar, and below is the ribbon toolbar. And in the right hand side, there is the Explorer panel, which is the easiest way to access the data and entry the results and the spreadsheets. So let's have a look into the RISA software. I created a short video. So this is the interface of the, I will show you the interface of the RISA 3D. Yeah, so this is, I'm opening the RISA Foundation. So once you open the RISA Foundation, you will see a screen where you can create your foundation model from the scratch, or you can open your existing model, or you can have the samples model that is provided from the RISA itself, and you will see the recent projects that you have been carried out in a foundation, RISA Foundations. And below is you will get options of the, if you are new to the foundation, RISA Foundation, you will get options of the video guides, all the tricks and the new features that are available for the foundations. So yeah, if you want to create new, you can just click on create new. You can create an existing project as well. If like for example, you have the samples model from the RISA that helps you to verify the foundation elements. You can just select and check it as well. And below is the recent project that has been carried out in the RISA Foundation. And like I mentioned, you will get all the video guides and the tips and tricks, all the features regarding the training information and the tutorials as well. So we are going to create a new project. So once you open that, you are going to get a page where you will get to fill your company information or the designer's name. So I'm putting my our company name, like the Acero Consulting Engineers, and as a designer, I will just use my name here, like my name, and that will be saved for your entire project. And so in the left hand side, you can see all the project information are being displayed. And like I mentioned, this is the ribbon toolbar, the menu toolbar. You have the options of new, open, save project. So you have the camera options as well to take the screenshot. And in the ribbon toolbar, you will get to see all the features, like in the home features. For example, here I will take a pause. You will get to select the units. Like if you are working in the imperial or the metric, you can just change the unit. And that will be applied entirely in a model. For example, if you have the load in the imperial form, and if you want to convert it, it will automatically convert all the loads from imperial to the metric. And in the setting tab, you are going to adjust some of the settings to your models. So for example, if you want to set up your mesh size, or if you want to set out your codes, you will get all the information from the setting tab, and you will get all the information regarding the concrete, the rebars, and the seismic through the model setting. So this is just a quick interface. And in the home tab, you are going to see your modeling related tools. So you will get to, if you want to design the grade beams, you can just have the options of the beam. Similarly for the spread footing, wall footing, you can see the piles, pile caps. So all of the modeling elements are can be accessed through the home tab. And for the walls, you can see the retaining wall, the strip footing for the gravity and the lateral. Similarly, for the piles and the pile steps, you are about to get such modeling tools from the ribbon toolbar under the home options. So you will get all the, like I mentioned initially, if you have remembered the circular slabs generations, there is the options of the circular slabs as well. And these are for the slab element, like if you want to create the design strip, there is some features, so there are some openings tools as well, like you can use from this like the ribbon toolbar. So next is the modify toolbars, where you will get to see all the copy moves features that will help you to modify the slab elements. And in the view tab, you can just adjust your view, like if you want to see in the isometric, or if you want to see in the plan view, or if you want to zoom any part of your elements, that you can do by the view app, like the view toolbar at the top. And next one is the drawing toolbars. Like you can see in the workspace, there is some grids because we have displayed the display the grid that is under the drawing tools. So you can just adjust the grid size as well. That will help you in the modeling process. Right now, you can see the X increment and the Z increment have been set. And if you want to hide that, you can just untick these options. If you want to set out the increment, you can just take it out. I am just making it 30 to the 10 so that you can see the grids has been changed automatically. Right now, I am just keeping it to the default value of 30 at the rate 1 feet. So in the spreadsheet options, you are going to see all the data entry that will be required for your modeling, like the material, the design rules, or the definitions for the footings or the soil definition, that you can do it from the data sections under the spreadsheet. Or also these things you can just define it from the right hand side. You can see the Explorer options, and you can define through the Explorer options as well. And the next one is the advanced tools, like you can see all the features like the database and the reverse features through the advanced tab. So this is the quick interface, and we will start, we'll jump into the modeling part later. So before starting the modeling interface, I will just quickly elaborate some of the key features. So like I mentioned, it has the modeling environment, which allows for the creations of different foundations element. Like you can see, it has like a CAD-like environment and the spreadsheet style editing, like which allows the quick numerical input and the easy modifications. Also, you can define the variable soil properties directly within the models, and there are some powerful selections tool that quickly help you to select the elements and do the modifications of slabs in a RISA foundations. Like the software also include the circular template. We'll also try to show that may be useful for the tanks and the round foundations. And you can also model the thickened slabs and the openings, which are common in the mat foundations. And finally, you can export, like the DX export allows you to bring in the CAD drawings and trace your the actual foundation layout. So we are going to see how the foundation element can be modeled. For modeling, as seen in the slide, I have a plan of the mat slab. It has some spread footing, it has some grade beams connected. We will create the grid as per this plan. So like you can see at the top, there is the like the grid, like 3 feet. Then after, there is some 25 at the rate of 25 feet, there is some spacing. Then again at the below, there is some spacing of 3 feet, and again the spacing of 25 feet. So we are going to set all this in the grid or within the RISA software. And outside that, there is some spread footing as well. There is some grade beams connected. So let's have a look like how we can model such in the RISA 3D, like the RISA foundation, sorry. So yeah, like I mentioned, we'll start from the home tab. Like in the home tab, you will see all the modeling related tools here. And once you click on any of the parameters, like for example, I have clicked on the spread footing, then you are going to see the property panels active in the left hand side. And this is the property panel where you can define a footing size. For a quick reference, I can just show you like how you can define all the parameters. So you can set out all the materials and the design rule for its footing. You can also see the pictures of it in sidewise. You can define the geometry, the length and width, the pedestal height, the soil properties, all for the footings. So similarly for the piles, you can just click on this piles option, and similarly like this, you are going to define all the materials and property information for the pile as well. And you can just save it for your future reference. So you can see it supports the different types of the pile, like, and it also supports the rectangular and the circular piles. So it's quite easy to select out your modeling tools. So similarly for the pile caps, you are again going to see and edit all of the parameters. Like you will see the pile cap, and below that there are the piles, and above it's the pedestal. You can just define all of the parameters easily. And it supports to have the numbers of the pile as well. You can select out different numbers of the pile. And you can just give the height to the pedestal as well if you are working with the pile types of the foundations. And besides that, there are the options of the boundary elements and the soil regions where you can just give out the parameters. So I've just created the pile file and I want to see it in the isometric view. You can just click it, and you want to see it in the render view. You can just click and see the render view as well. Right, so this is the quick interface, but we will create with the actual modeling. So this is just to show you like how you can utilize the modeling tools feature. So like I saw, we have these plans. So we will create some grids here, and we will start with the modeling. Right now you can see there is the offset of 3 feet, then there is the spacing of 25 feet, 25 feet again, then 3 feet. So there are some grade beams, there are some footings outside, and inside there is some pedestal, circular pedestal. We can just change the size, like the sections of the pedestal as well. We'll just demonstrate it. So right now I can just give the name to my model as well. Right now just I can save my file as well. So I can just write a name of any name random. So I am going to write a tutorial just for the demonstration purpose. And it is displayed, it is saved and displayed. So we'll start with the modeling of that plan. So right now I just want to create my grid. Instead, I just want to create my project grid that is available from the data entry tab at the right hand side. You can see. So I will just click on grid and set out the grid as per that plan that I have shown to you. So I've already selected the plan, like there is some spacing of the 3 feet, then some 25 feet. So I've already set out my increment in X and the Z directions. And so you can set out your grid spacing, and it will generate you the grid as well. Similarly for the X, I have already set out my parameters. So you can just set out your labels, like the naming from A to Z or Z to Y, and in the X direction, number from 1. So you can just adjust it as per your requirement. Right now you can see the grid has been generated. At the time you can just anytime you can just edit, like you can just edit the spacing of the grid as well. And in the view tab, there is some options of the zoom extent. If you want to zoom it, there is some options of zoom in and zoom out. And if you click on the zoom extent, it will take you to the default view. And I'm going to create my mat slab here. So for that, I am going to again on the home tab, and there is some slab elements. So the slabs, I'm going to utilize this tool, and I'm going just to give it a thickness of 30 inch. And you can select out the concrete material. So around the perimeter, I'm just going to select my node, and it will create me a mat slab. It is kind of a ELS for the plan. So I've already set out my grid. So it's quite easy for me to trace all the points. Yeah, so we have already created the outer mat, and then above is the pedestal that is shown in the blue color, the circular pedestal. We are going to create this as well, and we'll also create the grade beams and the spread footing. Now for the pedestal, I'm going to create the circular pedestal of the 24-inch diameter, and we'll place it above the slab. You can just give a height of the pedestal as well. So you can just place the pedestal in the slab. If you want to change any of its property, you can just edit it from the property panel that is active at the left hand side. And we have created the pedestal and slab. Now we are going to create some spread footing outside, and we'll connect it with the grade beam. You can just place it on the node, and it will create you the footing. You can just adjust your footing size and all that I have shown to you earlier. Like from the footing tab, you can just adjust the parameters. And in the intersections of that, there is some other like the footings, like there is some spread footing for spread footings as per the plan. So I'm going to create that as well. You can just use that in the drawing tools. You have the options of active at the top. If you click that, it will just keep that options active. And if you remove that active, it will just stop that action. Right now you can see I have just zoom in, and you can see I just want to connect it with the grade beams. You can just select, give the sections like the shape and the metal property. So once you click on this, the property panel is active at the left, and you can just assign all the properties to there. And you can just connect between it, and it will create you the grade beams. And while you are using these options, you can just continue it as well. Like I created the 3 grade beams here. And once I click on zoom extend, like I mentioned, it will take me to the default view. And if you want to see it in the wireframe view or the rendered view, you can just click there. And for the soil definitions, like in the left hand side, there is the options of the soil definition in the data entry in the Explorer tab at the left. You can just click on that soil definition and can assign your soil property. So by default, so I'm going to create the 2 types of the soil region, soil 1 and soil 2, with the different subgrade modulus. Right now I can create again the different soil region with the different subgrade modulus and the allowable bearing pressure. And right now you can see the soil 1 is by default, so that the overall region will be considered as the soil 1. And if you want to apply the soil region 2, you can just use the soil 2 that I will show here. Right now entire region is defined as soil 1 by default. Right now I'm going to create a soil region 2 for this of my spread footing. You can just select the parameters of the nodes, and we have already defined the soil definition so that it will be applicable in this area only. You can also see it has been denoted with some different color with the soil 2. That will help me to visualize graphically as well. and you can keep it in the isometric view or the rendered view as well. Right now you can see in the isometric view we have defined a model. The foundation is for the plan like this mat slab with some spread footings connected with the grade beams and with the different soil regions, and some pedestal, circular pedestals above it. Yes. Also, I have mentioned like you can just draw the circular mat slab using the template. So at the top you can see the circular slabs. So I will also try to show how you can use the circular slab generators to draw the circular mat slab. You can just give the radius inner and the outer radius. By using this feature, you can just apply the line load around the circular slab as well, or the overall area load, or you can just display this options off as well. You have all the full possibility. So you can just define the circular slab. So if I want to include this circular slab within the soil region 2, you can just change the coordinates by just selecting on any of the nodal point and just change its coordinates to the property bar that is active at the left. You can see on the screen. So the footings and the circular mat is in the soil 2 and all the other are in the soil default 1. So this is regarding the quick modelings of the RISA, like the foundation design, like the foundation modeling in the RISA foundations. So here I will show listed all of the loadings capabilities of the RISA foundation. So like you can graphically apply the loads. So this is the same model I have created and you can just apply the loads including the point load and the tapered area load anywhere in the model. Like the nodal load can be applied to the pedestal and the footing that I will show, and the line load can be applied for the slab regions. So you can also see the nested load combination mentioned here. Like you can define the nested load combinations. Like currently the combinations spreadsheet in RISA Foundation is limited to 10 columns of basic load case, and the factor combinations. Like however, there may be the time like when you need to include the additional entries to your load combination. So in order to all incorporate this, you can just simply nest your load combinations. And at last, obviously, you can soil overburden and the passive soil resistance can be included, which is important for the below grade structure. So let's have a look into how we can apply the loadings. So I will continue with the same model. So we have already modeled our elements, and before applying the loading, I will just, as you can see, we have modeled the pedestal as circular. I will just select few of the, I will show you like how you can select elements by property. Like you can see it's active, like in the left hand side, it has the selection toolbar. Above in the top, you can see the select by property. Then you can select it, and I will just select few of my pedestal and will change it circular to the rectangle. You can define the coordinate range that will be applicable to select all of that elements. We have just keep the coordinates tab active, and for the pedestal we are going to select it. And as you can see below the 6 pedestal I have selected using the selection toolbar, and that we are going to change its shape. So from circular to rectangular, we are going to change that pedestal size. So the others are kept as circular and it has been changed to the rectangular. So we'll apply the line load and line load to the slab, and we'll also apply the nodal load to our pedestal we have created, and also apply some nodal load to our footings. So for that, we can go on the distributed load, and you can just select the load case, and you can just click on apply. Where you want to apply the line load, you can just select the slab boundary within that regions, and you can just able to apply the loads. Later, we'll create the design strip for that area load where it will govern the maximum moments for the reinforcement. Similarly, right now we are going to select our node for the pedestal where we are going to apply the loading. You have the different options to select. You can just graphically select your node as well one by one, but I prefer to use the selection toolbar. That will, at a one glance, it will help me to select all the nodes. And once I've selected all my node, then I can select a specific load case and will give the magnitude of the load value and click on apply, so that you can see all of the loadings has been applied for the dead load. And for the live load, again, I can just change the load case and will apply the magnitude of the value. So this has been applied to the pedestal. Next, we'll apply it for the footings, like the 6 isolated footings we have created. We're going to select the node label, and we'll just select it, and it will select only my footing elements like this 4 below and the 2 at the right. And we are going to apply the nodal load to the footing for the load case. Yeah, this is for the nodal load, sorry, nodal load for the footing. So we are going to select our nodes again, 37 to 42. That is the 6th number of the nodes for this spread footing. Then we are going to use the load features again, and we are going to give the magnitude. And right now you can see at the outside and the below, the loading has been applied for the particular date in the live load case. And load categories, you can see from the data explorer below. You can just click on the load category and can see in the spreadsheet as well, like whether the load has been applied or not. So once we create the load case, we can just create the load combinations. We'll just use the load combination generator that will automatically generate my load combination as per the regions. You can just change it to the AISC or the IBC or load combination code as per the requirement, and it will just generate you the load combinations. And you can just see the load values graphically, like with the load combinations I've created. It will just take a factor, and you can just also display the loadings in the like the render view as well, like in the isometric view. Like right now you can see all of my models has been created with the loads applied at the pedestal and the footings. So yeah. And once we have done this, you can see right now it has been set to the imperial unit, like in the keeps. Like now, for example, in the metric, if we want to convert in the kilonewton, it will automatically convert to within the whole model. So you can just select it the units from the home tab. So right now you can see it has been converted to the keeps to the kilonewtons. So again, you can go back to the imperial as well. You just need to select whatever the units you want to work. So yeah, right now we have seen the modelings and the loading. So next is the analysis and the design. So RISAFoundation, use the finite element mesh to auto-generate for even the most complex software system. Like this is specifically, helpful for the large mat with the irregular shape. Also, the software lets you to assign the default or the multiple soil property, like I have shown in a single model, and it calculates the soil like the soil spring stiffness based on that subgrade modulus and the slab area to give the realistic result. And you can also create the design strip and the design cut on the slab to easily design the rebar. We'll also show case that to you. Regarding the piles, you can check the pile capacity to see like if any of the piles in the model are exceeding the allowable pile force. And the retaining wall module at the last allows the analysis and designing of the retaining wall as a part of the foundation system. So let's have a look into the analysis feature. Before that, I will just quickly explain you regarding the reporting, and then we'll just show the combined of both. So you have the options to graphically report your results graphically with the color contour of the slab. Um, Also, the software provides the deflection plots and the animations, like which are useful to understand how the foundation behaves under the load. And the additional features is the result information is available in the spreadsheet, where you have the options to filter out to print only like what you need. Like you can review and print the comprehensive detailed report of the foundation types, like the spread footing of the retaining wall. It also includes the expandable force diagram. Like you can see, it also has some the plans as well. You can get all this information in the detailed report as well. And last is it includes the rebar detailing for the slab and the beam design. And you can export the reinforcement plans and the details to the DXF format. So we'll just check the analysis and the design of the model which we have created. So we are just going to run the solve option, and it will just solve our overall entire model for the load combinations. And you will get to see the result tabs can be active at the below, where you will get to see all of the results like node reaction, the deflection, the soil pressures, and the code checks values, and the reinforcement, and the pile design. So all of the informations you will get to view through the reports, like the results tab. So you can see the plate force and the plate corner force are displayed, because when a model is solved, like the slab elements are automatically submerged into the plate elements, and therefore RISAFoundation display the two plates result spreadsheet, like the plate force and the corner plate force. So yeah, moving forward, you can see, you can just result your presentation by the items as well. So it will give you in the numbers like 1, 2, or 3. You can just filter it out. You can just sort it out, and you can see the multiples view, like the node reactions, the plate force in just one view, or you can just dog it into your workspace as well. Right now, I'm just closing it. So next is the design strip, they are used to create the design regions within the slab, and each of the design strip will contain the automatically define the design cuts, which will control the reinforcement design for that design strip. And the result for the entire design strip will be later determined by the maximum moment demand of the governing design cut, within that design strip. Yeah. And because one governing design cuts control the entire design strip, and it is critical that the good engineering judgment is used to determine an appropriate width of the design strip. So we'll also going to see how we can define this. So we are going to define the design strips at the top in the slab elements. You are going to see the options of the design strip, and we are going to see, you can just in the left hand side, the property tool is active, and you can just set out the rules and the numbers of the design cuts, and give the name label. So here we have applied some of the line load. So we are just going to create some design cuts here. We'll going to create the design cuts in two of the directions. So right now my angle is 0. I will just create a vertical design cuts with the angle 90 degree. And you can just change the number of the cuts within that region as well. Like why I have created the two design strip is under the two of the line loads, this is most likely place for the maximum moment because the design strip design the reinforcement in only the one directions. So you must add at least the two strip, one in the east of the directions. Then we are again going to solve our model. It will generate the mesh and then it will solve the model. Right now, again, you can see the result tab is active at the below. Now we are going to see the design step results as uh, well. In the left hand side, you can see the options. This is the options where you can, just select it to generate the report. You can see once you click on this and once you click on the design strip, you can going to get a detailed report. This include all the diagrams as well, moment diagram and the shade diagram and all the code check. And you are going to get the cross sections detailing as well. That you can include it in the detailed report as well. So this is just to check like what are the features available and what the results are you going to get from this introductory webinars. And we are going to check now the graphical results, how we are going to extract that. And in the left right hand side at the top, you can see once you completed your design, you are going to see that tab active. Similarly for the slab counters, if you want to see, you can just click that options and it will display in my model. The color contours of the slab, the soil pressures, the slab displacement, all of the values can be displayed. Whatever the information, the moments, values, you are going to get it in the graphical view as well. Similarly, for the footing as well, we are going to get all the unit code ratio as well. So for example, if you want to go it in the isometric view, again, you can just change its view. So whatever the information you want to see in the graphical view, you are going to get once you have run your design. Right now, I'm selecting it as none. You can just try it later as well on your own. And if you have any of the queries, you can just reach out to us. And right now, what I mentioned earlier is you can export it into the DXF as well. Like you can see the foundation plot plan or the pedestal details, all you can export it in the DXF. For example, if I want to export the foundation plot plan, you can just save it by giving a name. Just giving it a tutorial name and it will just, you can just save it and it will help you to select the units and the scale factors and you can just click on apply it and the DXF will be exported. So last thing we are going to get how to generate the reports once we have carried out all the design parts and the analysis. So in the top bar, you can see the camera icon. So from here, you can take the snapshot of your workspace and you can just include that image in the detailed report as well. You can adjust its size as well. And in the right now, I have my model here and I want to click on detailed report. Again, I am going to click on my detailed report options and with the one click, you can see all of my design checks for that particular pedestal has been generated. And in the top, you can see the options of print report where you can just print out your report. You will get to see your detailed report, your company names, and the designer's name will be displayed in the report as well, like you can see. That things can be customizable if you want to remove that logo as well. And if you want to put a company logo, you can definitely put that as well. And whatever the information you want to include you can just select it from the spreadsheet option. For example, if I want to select the pile definitions and if I want to scroll it, you can just add whatever the information you want to add. So for example, if I want to include the material takeoff as well, I am just selecting it, and under the detailed report, it is related to the design. So if you want to include the beams and the pedestal, and in the advanced tab, for example, if I want to include some of the image, you can see. So this is the report I have added from my, like I have opened my report and I have just added it to the detailed report earlier. So you can see that as well. And in the image options, whatever the screenshot we have taken, it is already saved here, and we can just import it into the detailed report, like the screenshot I have taken earlier from the snapshot options available at the top. If you want to include any of this in, like for example, if you want to include this snapshot at the top, you can just drag uh, from down to the top. By this way, you can just put place the sorting options, and in the left hand side you can see the print options, from where you can just print it into the DX, like the PDF formats of your report. So yeah, next is the integration part. Like the RISA Foundation is a complete foundation solutions that operate independently. At the same time, it is fully integrated with the RISA 3D and the RISA floor. In the left hand side, you can see, for example, in the director, you can see the RISA floor, foundation, and connection. This, like if you have the superstructure model, then you can just convert it into the RISA. You can just export your model into the RISA foundations, and all the reactions are automatically imported from the superstructure model into the RISA foundation for the design and detailing of the complete foundation system. And there is the complete load tracking between all the RISA products, meaning if you update the load of the member size in the RISA 3D, those changes can be reflected in the foundation model once you solve your model. And with the design complete, you can view the RISA foundation element in an integrated RISA 3D model as well. So I mean to say, overall, this integration result, results in major time savings and the much smooth design iterations process, like that may be valuable for your project as well. So this also provides the detailed case studies that shows the real project applications of the software. Like these are valuable resources to understand like how the complex foundation problems are solved using the RISA tools. This case studies also highlights like what challenges they are facing in their projects, and how the engineers have applied the RISA to overcome the complex design challenge. You can explore all of the case study available in the RISA website at risa.com, and you can just write the case studies. You will get to see the lots of the case studies. And the next is regarding the licensing and the portal. The RISA cloud-based, RISA is a cloud-based subscription license, offers a flexible system that requires, no named users. And moving on, you will see the customer portals. You can access it at portal.risa.com if you are already a RISA user. And it's a one-stop hub for everything that RISA provides. Like it is an online platform where you can manage your software license, or you can download the updates and access the support resources. It also provides the link to documentation, release note, tutorials, or the verification examples. That this portal can be linked, directly into the cloud licensing system. So you can log in and use the RISA from anywhere on any of the machine. In the right hand side, you can see the snip of the RISA portal, and in the overview, you will see the RISA products like that you are using. And in the user drop down, you can like the admin can add or remove the multiple users on the single license as well. And regarding the licensing type, the RISA Foundation license along with all the RISA license is a cloud-based subscription license, and where the multiple users can be assigned under a single license through this user portal, but only one active user can use it at a time. So the latest versions of the RISA Foundation is version 17 right now, which has been updated on the September of the month this year. So there has been some enhancement and corrections made in the version 17 as compared to the latest versions. Like I mean the last versions, which is the version 26. Some of the improvement are it has added the member design as per the AISC 360, and also added the ASC load combinations, generations, and several enhancement has been made to the model stability and accuracy for the different like the spread footing, the piles, and the pile caps. Also, the footing connectivity and alignment behavior has been improved, which is useful for the project with the continuous footing system. And the rebar optimization has also been improved by correctly applying the minimum and the maximum steel ratio limits that helps us to achieve the safe as well as the economical reinforcement design. Also, you can check all the additional updates through the RISA website as well. You will get to see all of the features that has been included in the latest versions. So this slide, summarize the today's session. We discussed about the RISA Foundation, and so like how it supports the foundation design. And I hope we also discussed its key features, design capabilities, and the applications across whether it may be the isolated footing, the mat, or the pile system. And we have highlighted its integration with the RISA Suite, which helps to reduce the manual effort. And we also discussed about where you will get to see the case study resources, and also regarding the licensing options. And yeah, I believe since this is the first introductory sessions, you get to understand how the RISA Foundation can be applied in a foundation project. So we will have some Q&A. We'll take some questions here, but before that, we'll display some of the poll questions here, and then after we can take a few questions. So you can see on your screen, just participate in the poll questions, then we'll move into the Q&A that we frequently received.
Great. We are getting a lot of responses, and yep. Thank you, Katie. Thanks a lot for that detailed demonstration of software. And yes, everyone. So you might notice a Q&A chat box at the top. So if you have any questions, anything you want to ask Katie or myself regarding anything commercial, something like that, we'll be more than happy to share the details with you. So please feel free to ask away any questions that you might have. In the meantime, I do have some FAQs that we get regularly regarding RISA Foundation. So till we wait to get some more questions in the Q&A box, Katie, I'll just ask you the regular questions that I face as a salesperson regarding RISA Foundations. First question that I usually get is what is the latest version US code available in RISA Foundation software, and does it support AIC 19 and ASC 710?
Yes, thank you, Ashwin, for your question. So yeah, regarding the RISA Foundation code, yes, it is well suited for the US code, and it support both of this code, like the ASCI 19, which is the 2022 approval, and for ASC 7, you may need to start the superstructure in the RISA 3D. However, the current load generation is specific to the building provisions in ASC 7 and does not cover the non-building structure, but this load will be need to added manually to your structures. And apart from the ACI, it also supports the Eurocode the 1992 Part 1 and also the Canadian and the Saudi code.
Thanks a lot, Kirti. Another question that we generally get is when exporting a superstructure model from RISA 3D, how does RISA Foundation transfer the reactions? We notice a slight negligible difference in the transferred reaction earlier. So what could be the reason for the reactions that are being transferred correctly?
Like you mentioned, so when you first integrate a RISA 3D model, like the fresh RISA 3D model, so only the boundary condition node are transferred over at first. Like the reaction that occurred in the RISA 3D model are transferred as load to the RISA Foundation model on a per load category basis. And as per my understanding, one reason regarding the slight difference between the reactions, like you mentioned, this has to be do with the P delta, which can change the distribution of force in the RISA 3D model. When load categories are transferred from RISA 3D to the RISA Foundation, they do not consider this aspect. So as a test, if you were to run a test load combination in RISA 3D that contain only, for example, the dead load and had a P delta turned off, then you would find the matching values. So you can also check by this way, and if you have any of the queries, then you can send us your model for more detailed clarification. We just need to check that. And I mean, when integrating from RISA 3D to the RISA Foundation, all the data comes from that same file.
Okay. Thanks a lot. So we haven't got any other question. Just one last thing from the FAQs. Is there a functionality in the software where we define number of piles from pile cap modeling in RISA Foundation, and does it provide rebar details?
Yes, the answer is yes. So RISA Foundation, you can define the minimum of the 2 piles and can go up to the 14 pile. Like in the demonstration part also, in the pile cap, I've shown you like you can define the numbers of the pile. So that you can go up to the 14 piles. That can be defined from the software template. While modeling the pile cap and the pedestal above it. So you can also definitely then adjust the pile spacing and the edge distance as well. I think so. The software analyze the load distribution among the pile and then design the pile cap by checking the bending and the shears, so providing the clear reinforcement requirement. It can perform all the pile cap code check that we will definitely include in our upcoming webinar as well, and also gives the worst case pile for the worst load case combination for the punching shear check code. So and definitely you will have the information for the pile cap, steel reinforcement, design force, and all the details, including the reinforcement detail. It consists all the pile cap elevations, the bottom rebar plan, the flexural and the shear plan for the pile, the pedestal rebar plans. So yeah, we'll also try to cover in our upcoming session as well. So I hope this addresses your queries.
Yep. Thanks a lot, Kirti. We have no further questions, so we can move ahead. So, everyone, if you want to, if you'd like to explore RISA Foundation yourself, we encourage you to try the free 10-day trial. It includes all the features and full support. You can download it directly from risa.com or simply write to us at solutions@acero.in and we'll help you get started with the software. Coming to some of the RISA customers, so RISA is trusted by engineering firms worldwide, from consultants to industrial design houses and infrastructure specialists. Its adoption continues to grow because of its speed, accuracy, and ease of transition from all of the platforms. So what do clients say about RISA? So RISA it's a seam. They usually mention the seamless workflow across its tools, exceptional customer support, and the ability to quickly evaluate multiple design options, helping team arrive at efficient client-focused solutions, even on the fast-track projects like yourselves. So at Acero and RISA, support is a priority. For RISA, we have dedicated channel phones for phone, email, and online help. About the licensing, so as Kirti mentioned, the licensing will be a cloud-based annual subscription, and it will be a flexible license, which means it's not limited to one machine, and you can switch between users and also add multiple users to the single license. Obviously, one user will be able to use a license at a single time, but there is no machine limitation. There is no limitation towards assigning and unassigning the license. It gets assigned automatically. So that's a big, I think, seamless option that is available here. And we also provide comprehensive learning resources. So we do webinars every month, and there are courses, tutorials, manuals, and knowledge bases available for RISA online. You can check out and explore the RISA Learning Center, that is training.risa.com, and you can get certified and also stay updated on the RISA content. So before we wrap up, we have also exciting sessions coming up in the month of January. So we have RISA 3D, which is a advanced software for 3D analysis and design. And we have All Plan, which is a leading BIM and design solution for AEC professional like yourself. Now, how to contact us? So here's our details. Our head office is based out of Noida, Sector 57. You can definitely, if you are anywhere in Delhi NCR, please reach out to us. You are more than welcome. And you can note down our number and our email ID. Both of these contacts lead directly towards me, and I'll be more than happy to provide you a quotation, set up a demo for you, and anything that is related to our portfolio. I'll be more than happy to accommodate you. And that's about it. So on behalf of Acero Consulting Engineers, I want to thank you all for joining today. If you like the demo session, I hope you like the demo session. And if you want any personal sessions, if you want a custom code or want to discuss the integration of these softwares with your workflow, you can reach out to me directly. Thank you once again for joining. And on behalf of Acero, very Merry Christmas and a Happy New Year in advance. So see you all in the next webinar. Thank you, Katie. Thank you.
Thank you, everyone, and a Happy New Year and a Merry Christmas.